So in this video, we're going to be solving a Leningrad Math Olympiad problem in which we have a system of equations with three equations. So since we have three equations and three variables, we should be able to solve this, and we're going to solve this in a bit. But before we go on, consider subscribing and ring the bell to not miss my latest videos, and hit the like button if you find this video helpful. Now, first of all, notice that we have three equations kind of in the same form, so that's beautiful. But the idea for solving this system of equations is to add up the equations. And actually, that's a common idea when we're dealing with system of equations. Usually, we would like to add up the equations and see what we can get from them. And that's what I'm going to do here. So let's go ahead and add up these three equations. So if you do so, we will have a squared plus 3a plus 1 plus b squared plus 3b plus 1 plus c squared plus 3c plus 1 on the left-hand side. And on the right-hand side, let's go ahead and distribute the 0.5 into the parentheses and then add the result. But before, let's just replace 0.5 with 1/2 because I feel more comfortable with 1/2. So let's just distribute 1/2 into the parentheses. So we will have b over 2 plus c over 2, and then a over 2 plus c over 2, and finally a over 2 plus b over 2. Next, let's go ahead and combine like terms on both sides of the equation. So on the left-hand side, I will have a squared plus b squared plus c squared, and then 3a, 3b, 3c, and then 3. And on the right-hand side, we should have a plus b plus c. So at this point, let's just go ahead and subtract a, b, and c from both sides. So we need to move this to the left-hand side. If we do so, we should have a squared plus b squared plus c squared plus 2a, 2b, 2c, and plus 3, and this should equal 0. So we have a nice equation here, and now we need to try to find a way to factor this, or in a way manipulate it somehow to be able to solve this for a, b, and c. So here's what I'm going to do. I'm going to rewrite the left-hand side in this way. So a squared plus 2a, and then b squared plus 2b, and then c squared plus 2c. And then we have a plus 3, but I'm not going to write this. Instead, what I'm going to do is that I'm going to break this 3 into 3 ones, and then I'm going to add 1 here, and here, and here, so that since we know that x squared plus 2x plus 1 is equal to x plus 1 all squared, we can use that and say that this is a perfect square. So this is a plus 1 all squared, this is b plus 1 all squared, and this one is c plus 1 all squared. So we have the sum of these three numbers, and the sum is equal to 0. And notice that this is non-negative, as well as this one and this one. Therefore, we have three non-negative numbers that add up to 0. So because of that, all of these three numbers have to be equal to 0, because if even one of them was positive, then the sum would have been positive as well, but it's not. So we should have a plus 1 equals 0, b plus 1 equals 0, and c plus 1 equals 0. And from this, we can say that a is equal to b is equal to c, and c is equal to -1. And this is the solution for our system of equations. And this should bring us to the end of this video. Thank you for watching this video. Please leave a comment. Don't forget to like if you find this video helpful, and subscribe for more contents like this. Hopefully, I will